Question 348, design tic-tac-toe from LeetCode. The question is asking us to design a tic-tac-toe game, and we have an n by n board, and we have two players. A move is guaranteed to be valid and is placed on an empty block, so we don't need to be worried about that. Once a winning condition is reached, no more moves are allowed. A player who succeeds in placing n of their marks in horizontal or vertical or diagonal row wins the game. So for designing this tic-tac-toe game, we are going to implement the tic-tac-toe class, which has two functions. The first function initializes the object, the size of the board, and the second function gets the information like the player's number or the columns and rows that we are going to put the marker. Let's see what a board like tic-tac-toe board look like. So let's say if n is equal to 3, this is a tic-tac-toe board that we can get. So if let's say the player 1 puts their marker, the markers here, so this is going to be a winning case when we have the same marker in the same row or the same column or a diagonal one, right, like this or like this. So either of these cases are a winning case. And one thing that we need to know about the diagonal cases is like we have only two diagonal cases. One is going the left diagonal, which is this case, and like considering this is like left case diagonal, what we can get from this is the if we minus the row indices from the column indices, we are going to get 0. So let's see, like 1 minus 1 is going to be 0, 2 minus 2 is going to be 0. So for this diagonal, we have a piece of information that row minus column index is going to be 0. How about the right diagonal one? So the right diagonal one is going to be like this, and this is a winning case. And what we can get from this is if we sum up the row index and the column index, this is the number that we are going to get, right? We are going to get 2, we are going to get 2, and 2 plus 0 is going to be 2, which is going to be n minus 1, equal to n minus 1. So from the right diagonal, we know the indices are n minus 1. Let's jump to the solution and see how we can solve this problem. To solve this problem, we are going to consider 4 different cases. The first case is when the winning is going to happen in a row, like the row 1 or 2 or 3, doesn't matter. The second case is when the winning is happening in a column, and the third case is going to be the left diagonal, and the fourth case is going to be the right diagonal. Considering these 4 different cases, what we are going to do, we are going to define 2 lists and 2 arguments for these different cases. And the reason that we are going to use list for the rows and columns, because we have n rows or n columns for each board. And in this example, we have n is equal to 3, so we are going to have 3 rows here. So we are going to have 3 rows. These are the 3 different winning cases that we can have. Or we have 3 columns, these are the 3 winning cases that we might have. And for the diagonal, we have only one case of the left diagonal and right diagonal, so we are going to put just 0 there, and we don't need a list. And for solving this problem, we are going to have 2 players. One player is going to put the marker X, and the other player is going to put marker O. And instead of X and O, which are a string and it's very hard to work with them, we are going to consider 1 for X and the player 1 and minus 1 for player 2. And what we are going to do in the move function, we are going to consider the case if there is a winner. We are going to check if there is a winner with this if condition. And if that condition is not valid and there is no more move, we are going to return 0, which means we have no winners. And if we return 1, it means the player 1 is the winner. And if we place the return 2, which means the player 2 is the winner. And for the conditions that we are going to do like have here, and what is happening here, we are going to update these variables and lists that we have defined here. How? Let's go through an example to better understand. So let's say we have the player 1 puts an x at index 0 and column 0. Instead of x, as I explained here, we are going to put 1 for player 1 and -1 for player 2. So 1, the player 1 puts a 1 here. What will happen here? We are going to update the rows and columns here. Because the 1 has been placed in row 0, we are going to update at index 0, in the row at index 0, this to 1, right? We are going to sum up the 0 that we have at index plus the 1 that we have here. So that's why we are using numbers. And because we are having the 1 at column 1 and index 0 for a row, we are going to update this as well. So we are going to have 1 and 1. The two other things that we need to check if the marker that we have at this cell, it's part of the left or right diagonal. So if the index minus the other index is equal to 0, it means it's a left diagonal. And if this index plus this index is equal to the length of the matrix -1, which means it's a right diagonal. So 0 minus 0 is equal to 0, so this is a left diagonal. And we just check that. We are going to see 0 plus 0 is not equal to n-1, so we don't touch this. Let's ask the player 2 to make a move. The player 2 make a move and put -1 here, which is at index 0 for the row, and it's here. 1 plus -1 is going to be 0, and it is at index 2 of the column, so we are going to update the column 1 to -1, right? And now player 1 makes another move. It's going to put 1 here, which is at index 0. We're going to update this for the row, and at column 1, and we are going to update this for the column 1. And I forgot to update the left and right diagonal for this case. Sorry, I'll go back. So for the right diagonal, we have 2 plus 0 is equal to n-1. So we are going to update the right diagonal, and 0 minus 2 is not going to be 0, so we are not going to touch the left diagonal. And for this case, we check the left diagonal and right diagonal, and this is not part of like either of cases. And now player 2 makes another move, and it's going to put -1 here. So at row 1, which is going to be here, we're going to change this to -1. And at column 2, we're going to -1 plus -1 is going to be -2. And now player 1 makes another move, and we check this is not part of a diagonal. So the player 1 makes another move. It's going to put 1 here. So at index 1 at row and index 1 at column. So what we're going to do, -1 plus 1 is going to be 0. And for the column is going to be 2 here at column 2. 1 plus 1 is going to be 2, and then we check if it is a left diagonal or right diagonal, and this is part of a left diagonal. As you see, 1 minus 1 is going to be 0, so we are going to add this one to 1 plus this to 1, and this is part of a right diagonal as well, because 1 plus 1 is going to be equal to and which is equal to n-1, so we are going to add this to 2 as well. And we ask the player to make another move, so it's going to put -1 here. So what will happen, it's going to be and at row 2 we are going to have -1, and at column 2 we are going to have -3. Let's put here, and then we check if this is part of a left diagonal, and it is part of a left diagonal because 2 minus 2 is equal to 0, so we are going to update this one. 2 minus 1 is going to be 1, and we are going to check if it is part of the right diagonal, which is 2 plus 2 is 4, so we don't need to touch that. And every single time we are going to check this if condition. What does this if condition do? So the if condition says we get the absolute. The reason is like we are having -1 for the player 2, so we should make sure this is absolute number, not the negative number. We check if any of these rows are equal to n that we have. Like the one we have here is -3 now, and if we get the absolute, it's going to be equal to 3, which is going to be the case here. So we have a winner. Or we check the diagonals if it is equal to n, or the right diagonal if it is equal to n. So either of these cases are true, indicates that we have a winner. And here we are going to check if the player 1, if it is the player 1, we are going to return 1, and if it is player 2, we are going to return 2. And in this case, because this is player 2, we are going to return 2. The time complexity for this case is 1, because we are not iterating over anything, or there is no for loop, so the time complexity is 1. It's constant time complexity, and the space complexity is n, because of the rows and columns that we have, that we are and that we are storing the values. Thank you.